In the field of artificial intelligence, generation speed and quality are often a pair of difficult-to-reconcile contradictions. Recently, a research team from Inception Labs announced a significant technological breakthrough: Mercury, the first commercial-grade diffusion large language model. Diffusion large language model, DLLM, which improved generation speed by 5 to 10 times while maintaining high-quality output. This video will provide a detailed explanation of this new technology from Inception Labs. Current large language models generate text using an autoregressive approach, which means they produce content word by word from left to right. This method has a natural limitation. The generation of the next word must wait for the previous word to be completed. Even with speed-optimized models, the generation speed on an NVIDIA H100 GPU can hardly exceed 200 tokens/s, 200 tokens per second. Let's first understand how autoregressive models work. Imagine you are writing a sentence, such as "The weather is nice today." The autoregressive model first generates then predicts the next word, whether based on and then predicts is based on the weather, and so on. This is similar to the thought process when humans write. We also decide what to write next based on the preceding text. The advantage of this approach is good contextual coherence, as each word fully considers the previous content. But the drawback is also obvious. It must generate strictly in sequence, unable to process in parallel, which leads to a bottleneck in generation speed. The diffusion model adopts a completely different approach. Its inspiration comes from the diffusion process in physics, though we can use a simple analogy to understand. Imagine you have a blurry photo. The diffusion model is like a process that gradually makes the photo clearer, in text generation. The diffusion model first generates a rough text framework, and then iteratively refines and improves this framework through multiple iterations until the final high-quality text is obtained. This coarse-to-fine generation process has two key advantages. First, it can optimize multiple positions in the text simultaneously without requiring strict sequential generation. Second, it can continuously self-correct and improve during the generation process. But it's like a writer drafting a first version and then revising and refining it repeatedly. Although this approach requires processing the entire text at each step, it can achieve faster generation speeds due to its ability to process in parallel. Mercury has adopted this new diffusion model architecture, breaking the speed limitations of traditional models. On the NVIDIA H100 graphics card, the generation speed of Mercury Coder Mini reached 1109 tokens/s, 1109 tokens per second, which is more than 5 times faster than the current fastest autoregressive model. Compared to some high-end models with 50 tokens/s, 50 tokens per second, the speed improvement is more than 20 times. In terms of code generation capabilities, Mercury also demonstrates impressive performance. In the human eval benchmark, Mercury Coder Mini achieved a score of 88.0%, on par with GPT-4o Mini. In the MBPP test, it scored 77.1%, close to Claude 3.5 Haiku's 78.0%. It is particularly worth mentioning that in the fill-in-the-middle test, Mercury Coder Mini significantly outperformed other models with a score of 82.2%, demonstrating its excellent code completion capabilities. However, Mercury also showed some shortcomings in certain tests. For example, in a live code bench test, Mercury Coder Mini only scored 17.0%, significantly lower than DeepSeek Coder V2 Lite's 37.8% and Claude 3.5 Haiku's 31%. This indicates that Mercury still has room for improvement when handling certain complex programming tasks. The advantages of diffusion language models are not only reflected in speed. Unlike traditional autoregressive models that generate text from left to right one by one, diffusion models can simultaneously see and modify the entire text sequence. This global perspective gives it unique advantages in two aspects. First is reasoning ability. The model can repeatedly review and refine the entire reasoning chain. For example, when solving a math problem, if it finds errors in subsequent steps, it can go back and adjust the previous reasoning process, rather than only being able to generate forward like autoregressive models. Next is structured output. Due to the ability to process text at multiple positions in parallel, the model can more easily maintain the overall structure and format of the text. For example, when generating code, it can simultaneously focus on the consistency of function definitions, variable declarations, and code logic, rather than generating it linearly line by line. This global optimization characteristic makes diffusion models achieve great success in the fields of image, video, and audio generation, such as OpenAI Sora, Midjourney, and Riff Fusion. Now, this advantage is also beginning to emerge in the field of language processing. Technological breakthroughs in Mercury may lead to several important application scenarios. First is the application of AI agent. Due to its faster generation speed and higher efficiency, Mercury is particularly suitable for agent tasks that require extensive planning and long text generation. Next is the improvement in reasoning ability. Diffusion models can complete error correction and answer improvement in a few seconds, while existing autoregressive reasoning models may take several minutes to complete similar tasks. The third is controllable generation. Mercury can edit the output content, generate text in any order, which allows users to perform text filling, security adjustments, or generate output that conforms to specific formats. Finally, there is the application of edge computing. Due to its high efficiency, Mercury can also run well in resource-constrained environments such as mobile phones and laptops. Currently, Mercury has started serving some early adopters, including market leaders in areas such as customer support, code generation, and enterprise automation. These partners have achieved better user experiences and lower costs by replacing standard autoregressive models with Mercury. Especially in latency-sensitive applications, developers often have to use smaller models to meet strict latency requirements. With the performance advantages of Mercury, they can now use larger and more powerful models while still meeting the original cost and speed requirements. This allows for greater flexibility and improved outcomes in various applications. Mercury represents a new direction in language model technology. Although there are still some limitations at present, its breakthroughs in speed and efficiency open up new possibilities for future AI applications. Inception Labs stated that they're already developing models for conversational applications and believe that in the near future, we will see more language model applications based on the diffusion architecture. What changes will this technology bring to the field of AI? Feel free to leave your thoughts and insights in the comment section. If you found the video content helpful, please give it a thumbs up and subscribe to our channel. Thanks for watching, and we'll see you in the next video.